Not the study guide, the test.
So if h of x is equal to the log base 5 of x, what would be the inverse?
Let me do it.
H of 5 equals.
Let Xavier try.
Oh. What we doing? Well, I need to get this.
You need the inverse of log base 5 of x.
It's gonna be H of 5, ain't it?
So 5 is now the input for the whole function?
Yep, we need some 5 of x. We need 5 for each of x.
You think 5 raised to the x? Well, let's look at what Joaquin just said. So, would that be the inverse?
Yeah.
Yes? 5 to the x? What do we need on the left-hand side?
H of x equals.
Not h of x.
Yeah, what?
What is the inverse notation for h of x?
G of x? H. Looking at this, I don't know.
It's h of x, so what's the inverse
X of
notation?
H?
H negative 1.
Oh.
Anytime that's the original function notation, that's the inverse notation.
So it's all gonna be that H negative 1.
If it's the inverse
It's gonna be inverse.
of what you started with.
So what if it start off like H negative 1?
It's
What
gonna
if it
be
start
H.
off like?
Then it would be the inverse of h negative 1 of x would be h of x.
So that's basically that over
Okay.
there. Now do it then, break time. Look, lick time. Come on, make it. Yeah.
It's like
15 more minutes of learning, that's what I heard.
Alright, can we stop at 5 minutes, please?
10,
I'll pray about it.
10.
Oh, I just erased it. I did mean to show you this really quickly. Hey guys, I did mean to show you this. Remember earlier when we talked about the, it was y equals b to the x and log x equals log base b of y?
Yeah, I pray about it.
Yeah.
I remember.
So here, remember we said that x, the input for the exponential could be anything, right? Which means that the output here could be anything. Do we see that the output, notice again, not x, but the output, can the output be anything?
Yes.
Goes from negative infinity all the way up to positive infinity. We said this y, the output here, had to be greater than 0. This input, does it have to be greater than 0?
Yes.
Yes. So I do want you to notice that those two ideas are tied together. Okay, so there's two really special type of logarithms, and you can write this down on your sheet if it's not space already there. And this is skipping over, to page 130, if you have your textbook. Oh no, you do have it. Yeah, you have it. I just skipped number 3. You already wrote, so, logarithms they were first conceived by this Swiss clockmaker. I don't know why he came up with them. I mostly know about John Napier developing logarithms, and we talked yesterday about Leonard Euler being really instrumental in the number e, and so he dealt a lot with logarithms. So there are two really frequent logarithms, and they are written in unique ways.
Common and natural.
The common log, which is what base?
10.
2.
10.
2.
10.
Dog, read.
Oh, my fault.
Log base 10 of x is equivalent to what?
C of x
C of
equals
x
log
equals log
x.
x.
Notice there, you can see how there's no base written.
Log of x.
So if there is no base written on that logarithm, then you know it's the common base and it is base 10. It's a lot like here, which root is this? Square root. Which root is that understood to be?
2.
Second, right? It was the inverse of that quadratic, right? So it's understood to be a second root. So anytime there's no base, means it's common log. It is the common log.
Which is 10.
Well, base 10. If you look at things like the Richter scale, which is what's used to measure earthquakes. If you look at, I believe, the pH scale for acids and bases, those are all based on base 10 things, so based on the common log. The other, and honestly even more common logarithm, is the natural log. And so, what is the base for the natural log? E. That's why it's called natural log, and because this base E shows up in literally nature all the time. And so if you see log base E of x, that is equivalent to, how have we written log base E of x in the past?
No.
No, my question is, how have we rewritten log base E of x? There's a different notation we use for natural log. Right. If you see ln of x, you need to know that that immediately is a logarithm with base E. So if you see ln, that is a log with base E. That is, those show up all the time. And if you take pre-calculus, they will definitely expect you to know those two things. Unfortunately, we're not getting as far as I want to in the...
Hopefully we don't take, I don't take pre-cal. I want to take,
The next math is, the normal next math is pre-cal.
what's the other one?
Algebra with finance, maybe?
Yeah, I want that.
There's that, there's AP stats, there's something else. Mathematical modeling, maybe,
No, I only had two. There was pre-cal and algebra.
with finance?
Yeah.
Gotcha. What's up?
Go San Antonio.
What?
San Antonio.
See, why the other people, they gotta take algebra too next year, I think.
What other people?
What other people?
Like the other liberators. Oh, they gotta
If they're in
take
geometry, then
Yeah.
they have to take algebra 2 next year.
See that?
But that's not gonna be allowed in the future. In the future, you will have to take geometry your freshman year. Sophomore year, you can take either algebra 1 or algebra 2, depending on what you did in middle school, or if you doubled.
Yeah.
Junior year, you have to take algebra 2 or a higher math class. And then senior year, you have to take something like pre-calculus, AP stats, AP calculus, mathematical modeling will be an option, applications of finite math will be an option. So like, you have to take something after algebra 2, after, or moving forward. Well, so they switched the order. It used to be that you took algebra 1 first and then geometry, and they very wisely decided to switch that so that you go from geometry to algebra 1 straight into algebra 2.
She does know what I did. Yeah, I was at CC. When I was taking
Okay. So, we're skipping this. Nope, this is where I want to be. So, getting into a logarithm. So talk the talk, this is one of the last pages. I want us to write down a summary. If you don't have your book with you, I would recommend that you write down this chart somewhere. So, basic exponential function. How do we write an exponential function in general?
That's great.
A times B to
Okay, and so a times b to the x, technically that a, you can think about it as a dilation. So we're just going to focus on b to the x, right? So good equation on that, Caleb, but we're going to focus here. So if h of x equals b to the x, that's the exponential. What's the basic logarithm?
A negative 1x.
So that inverse of h of x,
And it's gonna be x to the b.
x to the b,
No, b to the x. Log b.
log base. Stop with that.
Log
It's
B
not
to
to the x. It's not to the x. To the x is an exponent
Of x.
of x. Log
Log b of x.
base b of x. It is not an exponent. Notice how the b is a subscript. The x is in line with the logarithm.
Please print that out.
Huh?
Please
Print what out?
You just gotta draw it.
Just draw it. Bring your textbook tomorrow.
I'm gonna remember.
Watch the video and copy it down in your textbook
Take a
tonight.
picture of probably-
Alright. Now, quickly on a graph, what are some small things we need to pay attention to for the exponential function?
Credit to zero.
It don't never touch the
Increase or
index.
decrease?
So we're going to focus on exponential growth for this one. Okay?
X is
Anyone know what the y-intercept is gonna be?
That could be like 2, 3.
What's the x value known to be? 0. What is anything to the 0? 1. The y-intercept, unless there's a transformation, the y-intercept is gonna be 0, 1. Okay? What other key things should we know about an exponential function?
Good increase.
Not necessarily always greater than
No,
1. It's always
X has no restrictions.
no restrictions on x, so the x can be anything, but what about the y?
It has to be greater than 0.
Has to be greater than 0, so where's it going to start? Near the x-axis, and remember it's slowly increasing all the way through here, right? Until it starts to show major growth there. And so I want you to pay attention and make sure you're careful about that graph. It's approaching the x-axis, but it doesn't quite get there.
I have a question.
Yes, sir.
When it grow, when it cross the y-axis,
Mm-hmm.
and it starts to,
Intersects? Yeah.
when it starts to grow, does it ever become straight?
No, so it may look linear, just like it looks linear down here, but it's still, and even here, be careful, like it's still growing here. It doesn't look that fast, and it starts to grow more quickly after that, right?
Because it's constantly multiplying.
Because it's constantly multiplying, right? It's still constant multiplication down here too,
It's just
right?
smaller numbers.
right? So 1/8 times 2 is 1/4. 1/4 times 2 is 1/2, so on and so forth, right? So what are the things that we need to be careful about with log-based b of x? What do we know?
What about it's a reflection.
It is a reflection across y equals x, so are there any points that we will know?
Yes.
Which one?
1 comes equal.
There we go. We want to recognize there's going to be a 1, 0. What else do we know about this graph? For sure.
Y equals X.
It is reflected across y equals x, but like think about specific things over here that would
It's gonna
change.
be the opposite, or it's gonna be switched.
It's gonna want to switch.
The x and y are going to switch, so instead of the y having to be greater than 0, x has to be greater than 0. So what is it going to approach but never touch? Y-axis, right? So we want to be aware of that. And then, there we go. And so again, be very careful about showing that it approaches the y-axis. And so, I graphed these on the calculator as a base 2, because I couldn't do base b, at least on that calculator. And so we're going to use this graph to help us think through some things. So, domain of an exponential function, that's the blue one. What's the domain of the exponential?
Negative infinity.
Positive infinity. Okay, what's the range of the exponential?
0.
0 to positive infinity.
So let's pause there and look over at the the logarithmic function. What's the domain of the logarithm?
You said log. You can't get a
0 to
negative.
positive.
0 to positive infinity. What's the the range?
Negative infinity to positive.
Notice what happened to the x and y values? They switched, right? The range became the domain because the outputs became the
Inputs.
and the inputs became the outputs. Okay? What intercepts does the exponential have? A
Oh,
y
Y
intercept, which is
Y0.
1 comma 0.
not 1, 0. 1, 0 would be here.
0, 1.
Remember, with the input of 0 gets an output of 1.
1.
But for the logarithmic, we have an
1, 0.
x-intercept 1, 0. We're not going to worry about end behavior because we didn't talk about that this year, unfortunately. But asymptotes. Does anyone remember what the asymptote would be for the exponential?
Never.
Up.
No.
That's a line or a curve that the function approaches. Do you see a line that the exponential is approaching? The exponential is approaching the y-axis?
Exponential. No, it's supposed to
It's approaching the x-axis. which every point on the x-axis has a y value of 0. That's the asymptote. It's known as a horizontal asymptote.
Asymptote is y0.
So what would it be for the logarithmic?
Y0. Y-axis, basically.
So it's approaching the y-axis. Remember, the x and y switch, Xavier, so x is equal to 0. You better move quickly.
It was a good day.
I'm about to put up the
Good day.
reminders about assignments.
Are this gonna be on the,
How y'all feel? How y'all
Understanding
feel?
check tomorrow.
How y'all feel?
Some small things with logarithms, not those details, but there will be some small details about logarithms on the understanding check, because that is a big deal for what we're studying
When understand check on Thursday?
tomorrow. Tomorrow is Thursday. So please remember, I gave you a practice assignment to prepare for that understanding check. You will have time to ask some questions before the understanding check tomorrow.
Y'all better ask questions.
Well, you better actually try it to be able to ask questions. And then, these big idea graphic organizer concepts are due tomorrow. This is the only thing you have to turn in, but you'll be able to ask questions about this practice assignment tomorrow.
True. All right, Mr. King.
See you, sir. Anybody need me to leave it up there? Team.
trying to slide to the
You could be such a better student if you.
I should have packed up earlier.
Huh?
I packed up too early.